Have you ever wondered why hair ends up being straightened? I mean, think about it. You're taking this incredibly curly substance, one that wants to stay in a certain way, and you've now turned it into a perfectly straight strand. The reason behind this is simply because of due to the properties of proteins. What you're doing is taking a protein that's naturally curly or bent and causing it to become not the same shape or straightened out. How this happens and why this happens we're going to see today in a process called denaturing and how enzymes are affected by this process of denaturing. Thusly, you'll be able to explain why your hair goes from curly to straight when heat's applied. Think of it this way. Let's say this paperclip represents a protein in your hair. Notice how it's folded in a certain way. If this was actually part of your hair, you might end up with a curly hair. Or not quite as straight. Oh, I gotta turn my head this way. However, when you apply the curling iron to it and straightening, or a straightener for it, and you move down the protein, it begins to unbend and lose its shape. It then straightens out. Is this the original protein we had before? The clear answer is no, hence why your hair now would be straight. This happens all the time in your body, and so we're going to be taking a look at what do we call this when a protein loses its shape, as well as some of the things that can happen for this. Let's take a look. Enzymes Part 2. Remember, enzymes are a type of protein, perform a variety of functions. Properties of enzymes. Enzymes are incredibly specific. There's usually one enzyme for one substrate.
Catalytic cycle, the substrate encounters an enzyme with a specific active site to which it binds, forming an
Enzymes are very specific. If the enzyme loses its shape or the substrate is changed, it will not work.
Apart from the enzyme, leaving the active site free to catalyze another substrate as a cycle.
What can affect enzyme activity? When an enzyme or protein is damaged or broken down, it can get denatured. Denaturing is the act when you have a perfectly folded protein and you cause for some reason the protein to unfold or to lose its shape. This loses its specificity and it's no longer able to bind its substrate, thus making it an ineffective protein. As you can see, this protein has a normal shape where it's commonly bent. However, when we apply something to it, it begins to fall apart, straighten out, and lose its shape. That's called becoming denatured. It is no longer a functional protein as it does not have the same shape. What can cause an enzyme to be denatured? The two we'll look at today are acid or pH, as well as heat or combustible. Change in pH. pH is how acidic something is. Acids are corrosive and can cause proteins to unfold. The more acidic something is, the more quickly it will break down proteins. This is why whenever you get acid on your hands, you begin to feel a slight burning sensation. It causes the enzyme to lose its shape and not be specific anymore. That's why pickling food prevents spoiling. When you pickle food, you're changing the pH of the environment. It means that bacteria that would normally cause spoiling, their proteins don't work anymore because they've been denatured, thus keeping the food somewhat fresh. Heat. An increase in heat causes the protein to lose its shape. For example, when you crack an egg onto a pan, you'll notice that the egg itself is clear. However, as heat is applied to the egg, the clear proteins turn to turn white. That's because the egg's proteins are denaturing, straightening out, and losing their original shape. Example, cooking an egg will cause the proteins to go from clear to white. But what about cold? Cold does not cause enzymes to denature. It merely causes them to slow down. What are some other things that can happen to be able to denature enzymes? I look forward to seeing your answers. And then tomorrow we're going to be practicing with heat and pH and examining what it does do to enzyme activity. Have a good one. When it comes to the lab, this is a sample clip I pulled off of YouTube. The idea is still the same. I just hadn't bought the liver, so I wasn't able to show you accurately what was happening. But think of it this way. You're going to be taking the liver, applying it to the test tube, and then adding hydrogen peroxide. The type of liver will depend on which step of the lab that you're at. Adding one that's been pickled, one that's been applied to heat, and a normal liver, and one that's been chilled. All right? Have a good one. Notice in her sample how she has two different types of liver. Also see how she has the hydrogen peroxide, and she's going to be applying them to the two samples of liver. She measures out a certain amount of hydrogen peroxide. In our lab, it won't be nearly this much, as we have smaller amounts of liver and we want to conserve the resources. She then adds it to the liver and observe the reaction. Notice severe bubbling. In the other one, not as much bubbling. You'll be able to explain this why using denaturing. Realize that the hydrogen peroxide is being broken down due to catalase in the liver into hydrogen gas and oxygen gas.